Today we are going to discuss motion in plane, that is motion in two-dimensional space, that is along x-axis and y-axis. So let's begin our topic. What is projectile? Simple, when an object is thrown with some velocity having some angle under the influence of gravity, then this is called as projectile. Let's take some familiar examples. Motion of snowboard descending from a slope. You can see here, okay, that man having some initial velocity taking a parabolic path and come back to the ground again. This is example of parabolic path, and the motion that takes parabolic path is called as projectile motion. How does this parabolic path comes? Okay, let's see one more familiar example. A man rider performing a bike stunt. You can see the path, okay, the direction of the man is changing in the path. This happens in case of projectile motion. Now, what is the case for projectile motion, or how that parabolic path comes? Simple, when acceleration does not change with time. When acceleration does not change with time and velocity changes with time. Velocity changes with time. See, when acceleration does not change means acceleration is constant. Projectile motion is independent motion of x direction and y direction. So it is mutually independent motion, motion along horizontal direction and motion along vertical direction. In x direction, acceleration doesn't change. In y direction, acceleration is equal to negative of g. As you know, acceleration, what is g? G is acceleration due to gravity. It acts always downwards. So a is equals to minus of g. Here a is equals to minus of g, j cap for whole projectile chapter. Okay. Now what about velocity? Velocity changes with time. Direction of velocity changes. Okay. Let's take example. See, this is 2D plane, this is x-axis and this is y-axis. In projectile motion, x remains constant for whole path. X remains constant for whole projectile motion. But what about y? Y 0 at maximum, changes its direction and come back. So you can see one more example, motion of water jet coming out from nozzles. Okay. And this parabolic path is projectile motion. Now, let's take a look on idealized model of projectile motion. I told you an object is thrown some velocity with some angle. This is velocity and this is angle. You know that vector resolved into its components. Okay, vector resolved into its components, that is along x direction and that is along y direction. So, resolution of the vector. V vector along theta is V cos theta. V vector at 90 degree is V sin theta. Now take a look at different points for projectile motion. See, X direction for whole projectile motion is constant. X direction for whole projectile motion is constant. But what about Y? It first decreases, becomes 0 at maximum point. Okay, this is Vy, this is X component, and this is Y component. Vy becomes 0. From here again it begins to increase. So this is the main concept of projectile, that is X component is constant throughout whole projectile motion and Y component decreases, becomes 0 and then again increases. This is the concept of projectile motion. Now if you want to look velocity at any instant, then what and how can you find? Let us say that object football reaches at point P in some time t. Now what happens? The instantaneous velocity, the resolution of vector is there. So here Vx and Vy having angle alpha. Okay. Now initial velocity for the projection is ux I cap plus uy j cap, that is u cos theta I cap plus u sin theta j cap. Clear? Net acceleration along X component is 0 and I told you acceleration along Y component is minus of g j cap. So net acceleration is minus of g j cap, that is along Y direction. Now what about displacement coordinate in time t? So what is displacement? See, velocity is equal to displacement by time. So displacement is equals to velocity into time. This is equals to ux into t. Same for uy, that is you know the displacement equation, that is S equal to ut plus half at square. So y is equal to ut plus half at square. We are talking for y direction. So uy into t. Acceleration is equals to minus g for y component. So this comes out to be minus half of gt square. So coordinate at time t will be x equals to uxt and y equals to uyt minus half of gt square. Y equals to uyt minus half of gt square. Let's talk about projectile. Any object which is projected in the air is called projectile. Velocity of projection. Clearly, I have told you that velocity will resolve into its two components. But what about velocity at some instant? Or what about velocity after some time t? You know that at any instant, this will be the resolution of the velocity. Okay, at this point, the tangent to the direction is the resultant velocity. Okay, and if it resolves along the angle alpha, then Vx and Vy. So, at some time t, the velocity will be Vx I cap plus Vy j cap. Clear all of you? Now, as velocity is not changing in x direction, so it will be equal to ux only. Now, what about Vy? You know that first equation of motion is V equals to U plus AT. So, for y, V equals to U plus AT. We are talking for y direction. So, U is equals to Uy. A is equals to minus G. So, minus of G and T. So, velocity of y direction will be Uy minus Gt of J cap. So, this is the resultant velocity at some time t. Now, angle of projection. See, angle of the projectile changes for the motion. Okay, whatever the angle is here at the initial position will not be the same throughout the projectile motion. Okay, the angle will be different. Why? Okay, so if I want to find why the angle changes, let's understand. Okay, again, how can you find the slope? Suppose tan alpha is equal to Vy by Vx. Okay, and tan theta is equals to Vy by Vx. I will resolve this into two components, that is Vx and Vy. Okay, now you know that x component is constant. X component is constant for whole projectile motion, but y component changes. Due to change of that y component, the velocity changes, and the velocity changes, so angle changes. This is the reason that angle changes for the projectile motion at different instants. Now, time of flight. From ground to maximum peak, this is called as time of ascent. This is called as time of ascent. And from maximum peak to ground is called as time of descent. Is called as time of descent. What is time of flight? The total time traveled by object for projectile motion is time of flight. The total time traveled by an object for this projectile motion is called as time of flight. Now, time of ascent plus time of descent is called as time of flight. How will you derive the formula for time of flight? See, you are familiar with the second equation of motion, that is f equals to ut plus half at square. Here displacement I am taking as y ut plus half at square. Now we are talking for y component, so it is equals to uy times of t. Again a equals to minus g. I told you that for y direction a is equals to minus d. So putting a equals to minus g, what I will get? Minus half of gt square. I hope it is clear. Now, what is displacement? Displacement is shortest path between initial position and final position. See, if you initially project a stone, it goes up, and due to the influence of gravity, it again comes back. So displacement is 0. Okay. So I can write as displacement equals 0. So uy t minus half of gt square. Solving, uy t is equal to half of gt square. Square to t is cancelled. So uy is equals to gt by 2. T is equals to 2 uy by g. And what is y component? That is sin theta. So 2 u sin theta by g. So the formula for the time of flight is t equals to 2u sin theta by g. Now the question comes in your mind that how we can calculate time of ascent and time of descent. So to calculate time of ascent, divide this formula by 2. Simple, it is between two intervals. Now first interval is time of ascent and second interval is time of descent. So divide this by 2. So dividing this by 2, you will get u sin theta by g. Same for time of descent. Divide this by 2. So 2u sin theta upon g divided by 2 comes out to be u sin theta by g. So time of ascent is u sin theta by g, and time of descent also is equals to u sin theta by g. I hope it is clear. Now, next is maximum height of projection. What is maximum height? See, I told you at maximum point the y component of velocity is 0. Okay, that is v sin theta is equals to 0. Clear? From this maximum peak to ground, this is called as maximum height. Now, to derive formula for maximum height, you are familiar with third equation of motion, that is v square minus u square equals to 2as. Clear? We are talking for maximum height. So, velocity at maximum height is 0. So, it is 0 minus u square is equals to 2. Again, we are talking for y direction. So, a equals to minus d. And displacement I am taking as h. Now, minus of u square is equal to minus of 2gh. Negative to negative is cancelled. So, u square is equals to 2gh. From here, h is equals to u square by 2g, and we are talking for y component. So, in place of uy, we can write u sin theta. So, u square sin square theta by 2g. This is formula for maximum height. Horizontal range of projectile. Clearly you can see the point of projection, the distance between the point of projection to the total distance travelled by that object is called as range. Okay, the distance from the point of projection that object travelled for total time of flight and reaches to this point, distance is called as range. The formula for range. Now, range is in x direction. For time and height, you have to calculate along y direction. For time of flight and for maximum height, you have to calculate along y direction. But for range, we calculate about x direction. So, displacement into time. Velocity into r is what? Displacement. Range is what? Displacement. So displacement equals to velocity into time. And what is ux? X component is cos theta. So it is u cos theta into t. Now u cos theta, if I put formula for time of flight, it comes out to be 2u sin theta by g. So 2u cos theta, u sin theta by g. Simple. 2u square cos theta sin theta by g. 2 cos theta sin theta. Okay. 2 cos theta sin theta. 2 cos theta sin theta is equals to sin 2 theta. So u square sin 2 theta by g. So formula